The broadcast is now starting. All attendees are in listen-only mode.
All right. Hello, everybody, and thank you for joining our webinar today on understanding NFRC certification. My name is Laura Nail, and I am Intertek's marketing manager for the building products side of our business, and I'll be moderating today's session. Just before we do get started, I do just want to mention a couple of things just so everybody is aware you have joined today on mute. This just helps keep phone interference down for our presenters. But since you are on mute, if you do have any questions throughout today's presentation, just feel free to type them into that question box on your control panel. And then we should have time at the end to do a quick Q&A session with our speakers. We are also recording today's session, so a copy of the recording and the slide deck will be emailed to everybody, most likely tomorrow, if not definitely early next week. Today, our presenters are Mr. Kenny White and Eric Leitner. Kenny is our lab manager at our Fresno, California location, and he has over 18 years of experience in simulating and testing a wide range of products. And then Eric is our thermal testing and simulations manager at our York, Pennsylvania facility, and Eric has almost 20 years of experience in that field. With that being said, I will go ahead and pass it over to them.
Yeah, thanks, Laura. Hey, good afternoon, everyone. This is Eric Leitner. As Laura mentioned, I'm the manager for the Thermal Testing and Simulations Group out of York, Pennsylvania. Appreciate you guys joining in on the webinar today. Hopefully we get you some insight on understanding the NFRC certification process and kind of what we have and what we need and what's all involved from you folks to get certification on products. Real quick, we have just a short intro on NFRC in terms of what it is and what the program is meant to do. We have some basic information regarding computer simulations, thermal testing side, air leakage testing. We're going to talk a little bit about Energy Star, and then ultimately we're going to finish with the certification and how you actually obtain certification on the products itself. And then we will open up to Q&A if we have time at the end of the session. Short introduction around NFRC. The National Fenestration Rating Council certification program was developed to allow a fair, accurate, credible rating system of all fenestration products, which enable easy comparisons between products that folks are trying to buy for homes and other buildings. Some of the allowances within NFRC include different frame, sash materials, vinyl wood, thermal breaks, improved, non-thermally broken, etc. Also includes standard glazing packages, double, triple, spacer options, low-E coatings, tints, etc. NFRC basically has two certification programs kind of within itself. One being the product certification program, which is used mainly for residential and light commercial products, and then as well as the component modeling approach, or CMA, which is mainly reserved for commercial and site-built products. Today, we're going to be focused in on the project certification program, mainly for residential and light commercial. Next, we're going to talk quickly about computer simulations. On the side of the ratings procedure, two-step process, we need computer simulations, as well as the physical test to validate the computer sims. As we see here, we have sort of three individual ratings that come out of a computer simulation, one being the U factor, or NFRC 100, solar heat gain and visible light transmittance, which is NFRC 200, and condensation resistance, which is NFRC 500. U factor is the rate of the heat flow through the product due to temperature differential. The lower the number here, the better. U factor does not include any effect of solar heat gain or air leakage. It's just a true representation of the product itself. Best example of this is the poorer the U factor, the colder the wind is going to feel in the wintertime. Solar heat gain and visible light transmittance are ratios. So for example, if you have a 0.50 solar heat gain, means 50% of the sun's energy is transmitted through the product and into the building. Climates with hot summers want a low solar heat gain, which help with cooling costs in the summertime. And climates with cold winters want a high solar heat gain, which are going to help the heating costs in the wintertime. High visible light transmittance may be preferred depending on the application, which is going to allow more natural light to be brought into the building, which can help with lighting costs as well as heat. And condensation resistance, NFRC 500, is a scale of 0 to 100 to predict the product's ability to resist condensation. In this instance, the higher the number, the better, which is a good thing. This NFRC 500 is going to be replaced with the condensation index, which is a different value and a different calculation of how to get that number, but it essentially serves the same purpose. So what do we need for computer simulations? Straight away, we need some kind of an assembly drawing that shows the product here on the slide. As you can see, the kind of a cross-sectional view of a standard single hung product. Eventually, you're going to need bill of materials that list the finish for all components, the fully dimensioned part drawings, which include any component that you have, sash, reinforcement, glazing beads, etc., and a list of all of the glazing options that you wish to have rated for certification. Any of these items can include all variations of your frame, sash, and glazing, and anything that we don't get or is not provided won't be certified. We can always come back and add to it, but if we don't get that information up front, we can't offer it right away. Combination products or composite units are going to be certified as a single unit. So for example, if you have a fixed window over a horizontal sliding window, we'd actually separate those into two standalone products, one fixed and one two-light sliding window, and they'd be certified separately. This enables you to sort of build any combination of certified products without having to certify all of the unique combinations. Depending on the variations that you want to have simulated, it might be possible to simplify them by grouping. For example, if you need to, or if you offer your product with two different frame variations, one as a new construction and one as a retrofit, we can simulate those and compare the numbers between the two, establish which one is the poorer or the worst case performance, at which point both of those variations would receive the same performance values. Grouping is only recommended if you have variations that have a minimal impact or might have a minimal impact on the overall U-value performance. All products must be simulated with the exception of garden windows and tubular daylighting devices. Those are going to be test-only products because of some 3D implications. Part of the computer simulation process is going to be window, or what we identify as window software. This program was developed by the Lawrence Berkeley National Laboratory, or LBL. It's a software that has been recognized by NFRC as the go-to for simulations. When we construct glazing, we sort of build all the variations in the number of glazing layers, glass thicknesses, spacer thicknesses, gas fill, low E coatings, etc. All of these are probably the values that your glass supplier may provide to you, but those aren't going to include the frame, sash, spacer, or actual edge of glazing assembly, such as the spacer. For traditional glazings, it must be listed in the LBL's International Glazing Database. These records have been tested and added to the database as an approved layer. All the layers that we use for certification need to be approved. If you're working with a supplier whose glass isn't currently in the database, there is some kind of a lag there, possibly a few months to get it added into the database to be an approved layer. And all products that utilize domes, glass, and acrylic blocks or translucent materials need to be physically tested for U factor, solar heat gain, and for some products, visible light transmittance. Next step in the simulation process is going to be modeling in the THERM program, also developed by LBL. After we calculate the center of glass performance values, They're combined with the frame, each frame and cross-section and sash cross-section, which are then generated from the assembly drawings that we do get, which is going to calculate the overall frame and edge of glazing heat loss. I think as you can see here on the slide, they kind of have a typical head, sill, and interlock configuration. Each component is assigned a material and finish based on the bill of materials, which is important to know if it is, for example, a painted aluminum versus a mill finish aluminum. We need to know that up front. It's important to have that bill of materials be accurate, because if they are not, then the simulations could be required to be corrected. The material properties are going to be defined in the NFRC 101 materials library database. That database has a bunch of generic materials as well as a manufacturer supplied and tested data. Anybody can add materials to that database, assuming they go through the testing procedure. Otherwise, we're going to default back to a generic material. And then finally, we will then assemble sort of everything together as one to get one value. So the glass, the center of glazing, comes together with all the representative frame cross sections. The therm models, as I said, combine the center of glazing and the cross section itself. These calculations are going to be based on the NFRC standard sizes, which is important to know because all fixed windows, for example, are going to be rated at the same exact size. There are no minimum performance requirements within NFRC. It's an objective-based simulation which gets you a number. Those numbers depend on the product itself and how they perform. If you are looking for specific targets, it's always best to speak to the simulator ahead of time. That way they can sort of understand and identify potential issues, or can help guide you through the process to get those numbers that you need. That's it for simulations. I'm going to kick it over to Kenny here. He's going to discuss a little bit about the thermal testing end.
Good morning or afternoon, everybody, depending on what time zone you're in. As Eric mentioned, my name is Kenny White. I work at the Fresno, California laboratory, and I will be going over some of the physical testing aspects. So each product line that is simulated has to be validated, as we call it. So you can think of the validation test as a spot check against the computer simulations. The only products that don't need a validation test would be situations where you have two different products that are very similar. For example, a vertical sliding window and a horizontal sliding window often require only one validation test to cover them both. So the simulator will simulate both in separate reports, and then the physical test will be done on either one of them. Doesn't really matter. We need to, in order to verify this for sure, we use the assembly drawings that Eric mentioned, and then there are certain rules within NFRC that allow us to only use one sample for the physical testing. As with the simulations, the physical testing is done at NFRC standard size. So in the case of like a fixed window, it would be at NFRC's fixed window size, which is about 47 by 59. The configuration that we test needs to be one of the better configurations that's being certified. As the item that we physically test, its simulated U factor must be within 10% or 20% or 0.1 of the best value. And so once we test it, it's compared against the simulations, and then we have a 10% or 0.03 range at which the physical test must be within the simulated value. If it's within if it's within that range, it's considered to have validated, in which case all other simulated values in the report are considered to be good. For test-only products, such as garden windows and tubular daylighting devices, as Eric mentioned, there's no simulations for those. So we have to do all the physical testing for all variations. So while normal simulations, we would simulate all the glazing configurations and only do one physical test, since there's no simulations, all glazing variations would have to be physically tested. And that's for U factor, solar heat gain, and depending on the product type, the visible light. Once the product has been validated, we have to cut it up and compare it against the drawings that were supplied to make sure that they match. Any deviations between the drawings are reviewed with the manufacturer, and which could possibly mean that the simulations have to be updated. Air leakage testing. Air leakage is the rate of air that flows through the product due to a pressure differential. The lower the number, the better. A high air leakage can substantially lower the effectiveness of high-performing materials and components. Testing is done per NFRC 400 or the North American Fenestration Standard, often called NAFS, often called AMA 101. Per NFRC 400, the maximum air leakage for windows, sliding doors, and single panel swing doors is 0.3 CFM per square foot. And for double swing doors, it's 0.5. NAFS has a different set of requirements for the same products, but if it passes the NAFS air leakage, it's also good for the NFRC air leakage. Air leakage testing is optional for NFRC certification, but it is required for items such as Energy Star, California Title 24 compliance, and it could also be required by any local codes, or even just the architect or the consultant may require you to have your air leakage certification. Fortunately for me, the testing section is short, so I'm going to pass you back over to Eric, and he's going to go over the Energy Star and certification part of it.
Thank you, Kenny. Appreciate that. So I'm just going to go in a little bit here and talk about Energy Star. As Kenny mentioned, air leakage is a requirement within Energy Star, but Energy Star itself is not it's kind of outside of the scope of NFRC. It's the optional program that you may participate in that is, government-backed, recognizes certain products as energy efficient. As I said, it's outside of the scope of NFRC, but the recognized products must be NFRC certified, which meet or exceed minimum qualification criteria for specific climate zones. Here you can see northern, north central, south central, southern. The Energy Star recognizes only residential windows, doors, swing and sliding doors, like a sliding glass door, and skylights. Simulations and testing are conducted per the NFRC standards, as usual, but the manufacturer may decide to elect to participate within the Energy Star program once certification has been established. Energy Star has also developed the most efficient 2021 program, which really recognizes the highest performing products of each category, which kind of sets them apart from other products. Energy Star and Most Efficient 2021, as Kenny mentioned, may be required in certain building codes or for specific energy efficient buildings and projects. And lastly, I'm going to talk a bit about the actual certification piece. What happens here is that once all the testing and the simulations are complete, all have the reports and data has been generated, certification is obtained from a third-party inspection agency. They review our reports and data and issues the certification. To be clear, Intertek does not issue the certification for NFRC. That comes from a third-party inspection agency. Inspection agencies are going to perform in-plant audits to ensure that the products are built in the same way that they are simulated and tested. Part of the verification within the test and the simulation itself kind of goes beyond that with the in-plant audits to make sure that everything's on the up and up. Certification is going to last 5 years, at which time new simulations and testing must be performed in order to maintain certification, even if nothing changes with the product itself. Once the product has been certified, it is going to be listed in the NFRC Certified Products Directory, and NFRC labels can be applied to each product. Here you can kind of see the basic look of the label. Insulating glass is also an additional requirement that you must have certification per ASTM E2190, which is a seal durability test. All insulating glass suppliers you utilize are responsible for maintaining their certification. If you assemble your own insulating glass units, you are responsible for maintaining your certification. If you don't, you could have possible problems with certification, with it being delayed or suspended. The testing itself on seal durability takes approximately 15 to 18 weeks. So it's important that the certification is maintained. You don't have a lag. And as I mentioned before, the certification includes air leakage testing, which is required for Energy Star and Title 24 compliance. I think that's all I have. Laura, I'm going to pass it over to you if you don't mind, open it up for Q&A.
Okay, yeah, let's see what came through. Okay, so if you guys can't answer anything, just let me know and we'll follow up with somebody afterwards. But the first question is, if the validation testing score is better than the best simulation score, which one should we consider? For example, a window has a U factor of 0.21 in verification testing, but the best score in simulation is 0.23. Which one is valid?
All the values that you take from all the values that are certified are taken from the computer simulation. The validation test is just a spot check to verify the computer simulated values. So as long as it's within the acceptable tolerance, then it's good, and you use the simulated value. If it's not within the accepted tolerance, usually there's a discrepancy between how it's built versus the drawings, in which case that would be reviewed, it would be corrected, at which time typically the recalculation would validate. But in all cases where simulations are performed, the simulated values are the values that you would use for your labeling, your marketing, etc. The only time that you would use the physical test value is if you have something like a garden window or a tubular daylighting device where there is no simulation and only physical testing is done.
Perfect, thank you. The next one is going to be, is there such thing as windows and doors being built too tightly? For example, not allowing enough airflow. They're thinking about recent incidents of mold damage in houses and the possible causes of that.
I don't know about Eric, but I haven't heard of that. I do know that there are some products where people like to incorporate small ventilators to just help with airflow. So when the weather's nice outside and you want to bring some extra air in, I have heard of products like that. But I haven't heard of situations where a product is too airtight.
Yeah, I don't recall that either, Kenny. I'm just trying to think of a scenario here. I don't know. I suppose it's possible to be completely airtight, but I'm not sure what's more favorable here.
Yeah, I think it probably would be a kind of a mood issue, just because even a fixed window that was perfectly sealed, you're going to get, there's going to be plenty of air movement around from, opening doors and opening other windows that, it kind of would probably not be so much of an issue, but I haven't heard about it.
Okay. And then the next one is going to be, how long does certification take?
It depends on the scope of the project. For instance, a simulation could take a couple hours a day. It could take a few days if you have a lot of frame or sash variations. If you have hundreds or thousands of unique glass configurations, that all plays into how long it takes to do a simulation. The physical testing, the validation testing, typically takes 1 day. We'll set it up during the day. The test will run through the night. So if we condensed everything down, it's a couple of days to do the simulations and the testing, and then we have to do the cut up and product verification, process the reports, review them, etc. So it all depends on the scope of the work, and if it's one product or if you have 10 products.
Perfect. And then somebody else is asking, does NFRC have zones like Energy Star does?
They do not.
Okay.
Now, as Eric mentioned, NFRC is what you get from it are essentially just values. How they apply to different areas, that's where something like your local codes, like I know California Title 24 has zones, Energy Star has zones. There could be other situations where there could be something zones. But yeah, NFRC is just, think of it as you get what you get kind of thing.
Okay. And then another one, when simulating jam conditions of curtain walls, how do you approach this simulation modeling? Do you model per Therm Manual Chapter 8 or model as the intended physical specimens jam?
Yeah, that's a good question. Curtain wall modeling and testing is kind of odd when we're talking about NFRC applications. Yes, we would model this per the simulation manual, which implies that you centerline model this, which you think of the glass being on both sides of that jam or the vertical itself. Frame U factors are only assigned to half of that model, which includes the glazing on the adjacent side. However, for the testing, it's a little bit different. There has to be some kind of termination on the product on all 4 sides. Of that, the jam is going to be terminated where the glass usually would be, with some kind of a wood blocking or spacer.
Okay, and then how does NFRC and Energy Star work for site-built products?
Site-built products are, most of the time you're dealing with curtain walls or window walls, which Eric kind of just mentioned, how you would do a curtain wall. Window walls are similar overall, but as far as getting down to any specifics past that, we'd probably need a little bit more detail on the question.
Okay, and then with the virus in mind, is in-factory visits necessary or can it be done virtually?
That would be a question for the inspection agency. As Eric mentioned, we don't do the audits. We don't do the any inspections or anything like that. I want to say that they have opened that up, but I don't know for sure. To virtual, that would definitely be a question for the inspection agency.
Okay, and then trying to consolidate this one, I think she's asking, is the NFRC label only for the US market or what about Canada?
Eric might know this one better than me. I believe at least parts of Canada use the same NFRC that we use in the US, but I think other parts also require an additional calculation for Canadian. I think it's the temperature index. Eric might know that one better than me, though.
Yeah, you're correct, Kenny. Canada recognizes NFRC as a compliant program to meet Canadian building codes. However, some provinces may require CSA, the CSA method, which is very similar. It uses all the same methods per NFRC. It does include an additional calculation, an ER number, which factors in air leakage and solar heat gain and U value all into one big calculation.
Perfect. Okay, if you have a window from one supplier and glass from another supplier, will we test that?
Well, most window manufacturers are getting their glass from suppliers. Most don't fabricate it in-house. So normally that's not really an issue. If the question is more related to like relabeling or something like that, we call it reissues. Like if you're using a lineals from an extruder, that kind of changes the way we do things. But the only requirement at that point is what we mentioned, the ASTM E2190 insulating glass certification. As long as the glass supplier has that, your inspection agency will ask you who you use, and they will either have the certification already on file because they've already asked them, or they'll reach out to the plant. And as long as their certification is active, then you're good to use that glass plant, as long as it matches what we simulated.
Okay, and then who is the certification body to become Energy Star certified?
As far as I know, you contact the DOE or Energy Star within the DOE. We're usually not involved in pretty much any aspect of that, at least from my experience, other than being asked who to contact. Because once the certification is obtained, if the manufacturer has configurations that meet Energy Star, they would work directly with Energy Star, which last time I had to try to look that up, I just searched the internet for Energy Star for Windows, and I was able to find a starting point for to help the client on who to contact. But that's downstream of us, and typically, I don't get involved with that just because it's not an aspect of the NFRC part of things.
Okay. Next one, can the simulation and physical testing be done by two separate companies?
Yes.
Okay.
A lot of our clients prefer to stick with one office because all the documentation comes into us, and if there's any issues with the results not matching up, it's easier to compare notes. But otherwise, yeah, if it's simulated by one company and tested by another, as long as you provide all the information that both need, there's not any issues.
Okay, and then if you have multiple glass options for simulation, which glass do you use for the thermal test?
It'll be one of the better ones. I can't say it for sure just because there's such a plethora of options. But usually what I suggest is select your best low E, and if you have argon filling in your simulation, use an argon filled IGU. If you have triple glazed and double glazed, you're going to most likely want to go with the triple glazed to be safe. But past that, you don't have to use the best of the best, because we understand that is going to be more expensive. But it really should be one of the best, because otherwise it can cause problems with your certification. And you could also run into a case where if you add something significantly better in the future, it could cause problems, and you might have to do a new validation test. And so by testing one of the best or the best, it helps to reduce or fully eliminate that possibility of having it physically tested again.
Okay. Another one is, does vision glass and spandrel glass impact thermal performance?
At the moment, spandrel is not something within NFRC scope. They are working on developing the language such that it can be simulated within NFRC's scope. I haven't done any spandrel simulation. Eric could possibly speak more intelligently on spandrel than I could, though.
Okay. Eric, did you want to add anything, or do you want to just move to the next one?
I'm not sure if we lost Eric or if he's muted.
I don't know.
I guess we can move to the next
Yeah.
one. But yeah, if you do have a further question on Spandrel, you can reach out, and and we'll probably give it to Eric because he's got a little more knowledge on that than I do.
Perfect. One more, or we'll do a couple more here. Does Energy Star have separate labels, or are they combined with the NFRC labels?
There is a separate label that would be applied to the window, and in order to be fully compliant with Energy Star, there is a specific requirement for how close that label needs to be to the NFRC label, which actually I think I can put the NFRC label back up on the screen. There we go. So there would be a similar sticker to this one that would be within a certain range. I think it's a couple inches of the NFRC label.
Perfect. Let's see. Do you know if there are any updates to Energy Star? The person asking is currently working with 2015.
I haven't looked at the Energy Star updates in a little while. Eric did mention they've got the new 2021, best of kind of thing. I do know that every couple of years they tend to tighten things down a little bit, so it's definitely something to keep an eye on. Otherwise, what can happen, which happened a couple of years ago, is it snuck up on everybody, and the bread and butter glazing that a lot of manufacturers were using had just dropped out of the Energy Star range. So everybody was scrambling all at the same time to certify some additional higher performing glass, so that way they could still have a range of options within Energy Star. So it's definitely something to keep an eye out for. Maybe get on a mailer for Energy Star if they have one for updates. I'm not sure if they do. I kind of assume they do, though.
Kenny, I think it's 2016 is the current version.
It's been a little while since I looked at the chart.
The most efficient 2021 is just sort of a tiered, addition to the 2016 Energy Star requirements for windows and doors. Sort of a higher level performing windows.
Perfect. This person's asking, are they correct that labeling applies to products and not necessarily systems?
Well, those often are used interchangeably, so I'm not sure what they mean by systems, other than maybe like composite or combination assemblies. If they're referring to that as a system, the way that would be done in the example Eric used of a fixed over a sliding window is you would label the top fixed portion with the fixed sticker and the bottom horizontal slider section with the horizontal slider sticker. If that's not the correct example, then we'd need clarification on what they mean by system.
Okay, yeah, we can follow up with them afterwards. Don't know if this will be something that you can answer, but just let me know. They're asking if you can speak on bird safe glass testing certification at all.
Oh, I have only heard little bits about that. I don't have any recent memory of any knowledge. I'm not sure if Eric does.
I'm not certain I know, although I wonder if it's safety glazing testing, which is a little bit outside the scope of NFRC.
Okay.
I know NFRC, I think there is a task group within NFRC about that, or at least there used to be. I don't know if that got tabled or not. Certain work groups get developed based on, basically kind of feedback from the market as to what needs to be in there. And I know there was some discussion about bird safe glass and testing, at least to some degree, but I haven't heard anything about it in a little while.
Okay.
That might be something to maybe reach out to NFRC or check NFRC's page for like work groups, task groups, that kind of thing.
Perfect. Okay, we'll do one more here, and then if I did miss anybody, we will definitely follow up with you afterwards via email or phone call, whatever Eric and Kenny are able to do. Do we have any European labs that carry out these tests? Do you guys know?
I want to say none that I know of, but I haven't looked at NFRC's site that lists out all the different test labs and sim labs in a while. But I want to say no because Europe uses a different method, and so usually the labs that are over there are doing what the European market uses.
Okay. Perfect. All right. Well, I'm going to stop it there. Like I said, if I did miss anybody, we will follow up with you. And then for anyone asking about recording and getting copies of the slides, we will definitely get that to everyone who attended today. But thank you to Eric and Kenny for presenting to us and taking the time out of their day. And thank you all for joining us. And I hope everybody has a great rest of their day.